Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we will try to get to as many as we can near the end of today's webinar. And also at the end of today's webinar, we will be doing a drawing for 6 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 6 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is how to stand up an application security program fast, a practical and strategic approach. Our speakers today are Thaddeus Walsh, who is Solution Architect at ZeroNorth, and Joanne Godfrey, who's Director of Product Marketing at ZeroNorth. Welcome to you both. Thanks so much for joining me today.
Thank you, Charlene, and welcome everyone. Thank you for joining our webinar today. So Thaddeus, why don't we just jump in and kick things off with some background information on what is an AppSec program and what does standing up an AppSec program entail, and what are some of the things our audience needs to think about when they're thinking about starting up an AppSec program?
Yeah, absolutely. So there's a bunch of pieces that go into an application security program. I would say some of them are kind of meta components and some of them are functional components. And what I mean by meta components is the core principle of an application security program is inherently a commitment between the security organization and the development organization that would remediate, fix, absolve issues over time. If you don't have a discrete commitment between security and development, that's your primary goal, is to get a formal agreement and commitment in writing. Now, inherently the commitment arrangement looks like whoever is responsible for quote unquote security is responsible for finding the issues, and the development organization is responsible for fixing the issues. Everything else is done with the lens of whatever is best for the business. So how you scan, what you scan, when you scan, what gets fixed, when it gets fixed, how it gets fixed. Those all are kind of nuanced pieces of the puzzle, but ultimately all of those subsequent decisions get made with the context of whatever's best for the business. And so some of our audience members may be thinking, well, my development team isn't super interested in me running assessments during build pipelines, or they don't want to hear about kind of the litany of issues that they have because they have such a deep backlog already. And so if you do have somewhat of an uninterested or uncooperative development group, it's really, it's like the wind, it's erosion. It's about consistently presenting the same message of, we need to do this securely. It's a risk to the business, the same way that financial risk or market risks exist, and we need to address this from an application security perspective. And over time, people change, people's perspective change, events in the news happen, and any of those things can be a tipping point in terms of lighting the fire under an organization-wide perspective transition on how to run an application security program or how important application security is. So the more functional pieces of an application security program are, I like to refer to them as plumbing. So the plumbing of an AppSec program is really code. It's engineered work that lives in pipelines, that lives in suppression rules that are configured within the tools themselves. But it's also in terms of processes. So what is the process that you use to scan different things? What do you scan? How do you scan it? What tools do you use? And then subsequently communication processes. First, communication from the application security team to a business risk decision maker, And then subsequently, depending on what that business risk decision maker decides, what ultimately gets communicated to development. And then lastly, and this is more kind of business programmatics, but continual process improvement, continual programmatic improvement. So any AppSec program has to have a way to self-reflect and identify success. So, and that's going to vary organization by organization, depending on what the business's goals are. Some organizations are really focused on AppSec because they fall under compliance requirements. In order to do in order to participate in the business that they participate in, they have to meet some specific standards, and that may or may not include application security. Other businesses may hold large quantities of personally identifiable information to their customers, and it's a perceived risk that exposure of that information would tarnish the brand, hurt future revenue generating opportunities, so on and so forth. And so different programs will have different goals, and there needs to be an intelligent kind of, unique to your business way of evaluating that. A lot of folks kind of ask, well, like, what are some examples? The most straightforward is like, how many critical, high, medium, low severity vulnerabilities do you have across all of your applications? It's not a great measure or metric, just because it disincentivizes scanning new code. Because when you scan new code, you inherently find all of the backlog of errors or flaws or weaknesses that exist within that code. And so I typically don't prefer that sort of a measurement. Oftentimes it's, what percentage of issues that were communicated to a remediator were resolved within an SLA guideline, or what is the percentage total number of business applications that are being scanned as part of the full application security program. So not just one scan, but all of the scanning activities and events that would occur for a fully matured and onboarded app. Those are more realistic for an AppSec team. And part of the challenge is because application security doesn't fix anything, you can't really measure them on the quantity of vulnerabilities. It's kind of unfair. It's like, you're identifying these things as they come along, but you're being measured on the rate that they're being addressed and absolved. So that's really the guts of an application security program, is the plumbing and that commitment between security and development.
So thank you. The commitment between security and development is obviously crucial. But let's talk a little bit more about some of the processes, and specifically the scanning processes, which is where that commitment is really realized. Can you explain a little bit about the different types of application scanning and how and where and when they all fit into this software development process?
Yeah, so most people envision software development lifecycle as a circle or a wheel or a loop. In reality, it is a bunch of lines that are kind of laid out iteratively. So you would follow that process continuously, where runtime deployment, identification for opportunities for improvement would lead back to ticketed requests, changes to source code. From an application security perspective, there's essentially a conveyor belt from when a developer lays code into a development environment all the way through runtime instance existing, running on some infrastructure somewhere in production. And so if you look at that conveyor belt from original code creation all the way through runtime, there's a couple of discrete kind of stages of the application delivery life cycle, and there are different assessments or application security assessments that can be executed at each of these stages. It's important to note that you will not have a comprehensive enough picture to adequately secure your application by running one type of scan at one stage. All of these different assessments exist as different products or different open source projects or different service offerings from MSSPs and things like that, because they provide a different lens to the same thing. It's all the same build, it's all the same iteration of a particular application, but it's all meant to achieve a different level of understanding. So I'm just going to breeze through these pretty quickly, and as Charlene mentioned at the top, if there are questions, feel free to post those into the go to application. So first and foremost, static application security testing, or SAST, is the evaluation of source compiled or binary code. This is one that most developers are even familiar with in a lot of ways, just by bumping into it throughout their their careers. Basically, everybody should run this. It's the deepest look at the code itself. SAST tools approach the process of evaluating static code in different ways, and they all tend to have kind of a patient zero, a particular application for an early client that drove a lot of the vision or a lot of the architectural decisions within the application that make it stronger or weaker in a given language or a given framework. SAST tools can't specify vulnerabilities. So there is no static assessment tool in the marketplace today that you can run that will certifiably tell you this will be an exploitable vulnerability, in part because it doesn't have visibility into the infrastructure layer, doesn't have visibility into compensating controls that could be in place. But ultimately, we don't have software today that can intelligently deconstruct an application to an extent where you can certifiably state that a vulnerability exists. Oftentimes, calls will be noted as vulnerable or as a potential weakness, but that would be obfuscated by the fact that there's no user input capability. It's all the inputs are derived from some more exterior process that a user may drive. So we oftentimes see a large number of false positives, and typically SAST assessments require tuning. So I mentioned suppression rules earlier as a common thing that organizations run into and spend a lot of time on. SAST tools tend to take a long time to run because code is complicated. There's about 1 trillion ways to make the same mistake. And so the goal of a static assessment tool is to identify all the ways that you could make that mistake comprehensively every time, because obviously a false positive is introducing risk into the world that you aren't aware of. It's important to note not every SAST tool supports all languages, or the assessment quality can vary greatly, and some languages or frameworks require compilation before assessment, like Java or .NET. If you don't have classes, you can't assess Java code. It just doesn't work. And that becomes important when it comes to operationalizing these sorts of tools. Software composition analysis, this is looking at third-party packages. So as I'm sure most of our audience is familiar with, you pull in third-party dependencies in order to build your application, run your application, and those third-party code packages could have vulnerabilities associated with them, and your application may inherit those. And so this is basically just looking at a manifest of what third-party packages were drawn in at build or were declared as part of a requirements.txt or a packages.json, and then doing a cross-reference against a big honking database of, these are all the vulnerabilities associated with this third-party package at this version, so on and so forth. Some of those are public-facing. If you're not familiar with NVD, the National Vulnerability Database, that's a program that's run by NIST, and it's public-facing. It's the gold standard in a lot of ways, but oftentimes software composition analysis tools will also maintain their own databases of additional third-party dependency vulnerabilities that their research groups have discovered or that don't appear within some sort of a discrete security bulletin, which is a lot of what drives NVD. And most importantly to note, there's often a very large difference between pre-build and post-build software composition analysis. The reason for that is if you draw in a package and that package has dependencies, you wouldn't necessarily explicitly declare your dependent package's dependencies. All of the compilers and almost all of the kind of higher order build wrapping tools are intelligent enough to kind of greaseball down the line of dependencies until you have everything that you need for your application to build and run. The problem with that is if you run a pre-build SCA evaluation, it's very likely only going to evaluate for vulnerabilities directly associated with the declared packages, not all of the packages that will come in as a result of those primary declarations. We call those transient dependencies, and they can be nested and very difficult to identify if you don't assess post-build. So the next stage of an application's lifecycle could be that you wrap a compiled build in a container. And for those of you who aren't familiar with containers, because you may have been living under a rock or something, super high level, a container image is a template for a virtualized operating environment and hardware dependencies, a list of software dependencies, and then application code. And so what a container scanning tool does is identical to a software composition analysis tool, but it's assessing the software dependencies declared at the container image level. And that's super important. If you run software composition analysis and you don't run container scanning, you may have no vulnerabilities associated with third-party dependency packages in your source code, but you may have third-party vulnerabilities introduced at the container layer. So if anybody's familiar with Docker, Docker Compose, Docker file, composition methodology, the first line is going to be from and then some base image. And that base image oftentimes is pegged to a specific version of an image. That could be Ubuntu, it could be CentOS, it could be, whatever baseline, Alpine, if you're familiar with the ecosystem. The issue is most developers don't tag to latest, which is a dynamic tag. It represents kind of whatever is the latest version of that thing, because that can introduce instability into the container image as it is produced through iterative build times. So instead, most developers find a good stable version of their baseline and then totally forget about it and don't touch that version number for as long as they can possibly get away with. The problem is the research organization and malicious software developers, meanwhile, are identifying new vulnerabilities associated with that container baseline. And that may be because somebody's trying to break CentOS directly, or because somebody's trying to break that CentOS image baseline directly. But ultimately, you may be inheriting third-party dependency vulnerabilities associated with that baseline that aren't reflected in your application code. And that's exactly what container scanning does. It takes those software dependencies, goes and triangulates, are there any vulnerabilities associated with them, and then brings that back as a report of the known available vulnerabilities associated with those underlying packages. And then next we come to dynamic application security tool. So when we talk about dynamic assessments, we're talking about addressing a runtime instance. Now that runtime instance could be in a QA environment, it could be in staging, it could be in production, but somewhere, somehow, your business's application is running, and there are tools that are meant to exhibit attack type behaviors against that web application. Important to note, if a dynamic application tool or assessment tool can identify an issue, it is a genuine vulnerability. If an actor from the same point on network is able to access your web application in the same way that the dynamic assessment tool was, then they would be able to exhibit exactly the same attack behavior that the DAS tool enumerated. So these are typically where people put primacy in terms of remediation efforts, namely because there's a high degree of confidence in contrast to static assessments where it may materialize into an in vivo real world vulnerability or not. So the biggest headache associated with DAS tools is you need to essentially get past the login page. There are very few web applications that just kind of exist, and there's no user-specific authentication modality. Most of the time, if you think of like logging into your bank's website, if you were to run a dynamic assessment against them, and please don't, because they would not be happy with that, you would get information about the login page, but your dynamic assessment tool doesn't have the intelligence to get past that login page. So if there's a vulnerability in whatever page presents your different accounts, your checking, your savings, whatever, the DAS tool would never see that surface area of the web application, so it would never be able to evaluate and identify those vulnerabilities. The problem is modern day authentication protocols and frameworks and models are all meant to defeat software-based login. So part of the challenge is, how do you build an application that's secure at runtime in production that can also be assessed by a DAS tool. And that's tricky. It depends on the application. There's a million different ways to go about doing it. Would be happy to chat with anybody about that sort of headache down the road. And then in addition to DAS, there's obviously also pen tests. So a penetration test is a human-based assessment, oftentimes tool-assisted, but it's an exploration and discovery against a runtime application. It's generally understood to be that a pen test is going to be more comprehensive than just running a DAS tool, or even multiple DAS tools. Why? Because humans are great at pattern recognition, because trained individuals are generally better able to fine-tune attack type behaviors given information that they perceive from just interrogating or investigating the surface area of an application. And so it's much more flexible. The problem is it tends to be substantially more costly than just executing a DAS scan, and they take a lot more time than an automated tool. So, best recommendation, both. Pen test as much as you can, DAS as kind of an in-between, not necessarily a maintenance mode, but you can just get much better coverage from a DAS tool than you can with a pen test. And then finally, infrastructure vulnerability management. We're talking about scanning the underlying infrastructure and assessing the cloud environment where that infrastructure may lie. If it is, say, an AWS or Azure instance. So scanning the network addressable host infrastructure is different from a DAS. There is some overlap, like they'll find some of the same vulnerabilities. But instead of trying to interrogate the web application, what a network scanning tool is trying to do is it's trying to execute attack type behaviors against the NIC, or the network interface of the host that's supporting that web application, so that you can gain unexpected access, escalate privileges, perform or get information about the device that you shouldn't be able to get information about to further inform additional attacks, that sort of thing. And then finally, cloud audits are a category of assessment that interrogates the configuration of your kind of cloud account, so to speak. So it's not looking at the assets necessarily discretely to find out is the network interface of my EC2 instance vulnerable. It's looking at, are the permissions associated with this role overly promiscuous because it allows for arbitrary creation of additional accounts and things like that. It does get into interzone security, such as are the ACLs configured in a declarative way, or is it all access between these two virtual networks and things like that. So that's kind of the final lens that you can sort of apply before you really start to get into hardware security and things like that. And so our attitude is you should probably be doing all of these to varying degrees. Like an ultimately mature AppSec program would be exhibiting all of these different activities. And that sounds daunting. You shouldn't start by saying, I want to do every single one of these throughout for all of my applications. But it's good to note that, even if you get a really sturdy, robust kind of dynamic assessment protocol in place, you're not at the end of the road. There's still much more to be seen and many more attack vectors to be assessed for that oftentimes a dynamic assessment tool is just not going to be able to see. So I know that was a lot of info, but again, feel free to bounce into the questions panel.
Thanks, Thaddeus. And we can see there are a few questions. We will get to them at the end. Thank you. And please do continue to submit your questions. So back to the webinar. So running these application scanning tools is great. And thank you for that overview, Thaddeus. But alone, they don't inherently reduce business risk. So how do you translate these outputs from the scanning tools into business risk? Meaning, how do you make decisions about risk and what you need to do to reduce that risk? And how does an application security program serve the overall business decision making process around risk?
Yeah, so and I just took a look at some of the questions, and a lot of them are fantastic. So I'm excited for this Q&A. So I'll try and move quickly through kind of the last segment, which is, okay, so you've got an application security program, you have an agreement between dev and sec, and then you've run a bunch of scans, and now you have kind of a glut of vulnerability data. What do you do with that next? There's really only 4 possible responses once you've identified an issue or a vulnerability. You can accept the risk, which is the same as writing off the risk. The business is acknowledging that the risk exists and is comfortable with the potential, the potential outcome that it represents, or it's confident that the likelihood of an attack against it or an exploit against that vulnerability is sufficiently low that it's not worth the remediation effort. So that's risk acceptance. That's kind of the lowest level of effort, because you just document that. Typically recommend that you revisit those things on, at the very least, an annual basis, hopefully a quarterly basis, so you can kind of rationalize over time. The second option is kind of the second most straightforward, which is remediate. So you identify the root cause of the vulnerability, and then you remediate it. For a third-party code dependency vulnerability, that could be updating to a newer version of that third-party package, where the third-party developers already solved for that problem. When it comes to first-party code or SaaS-discovered vulnerabilities, it can get a lot more complicated, right? It can be, completely re-architecture your entire application. So remediation is taking action to remove the root cause of the risk, not necessarily remove the software component or the functionality where that risk originated, but to resolve the risk at the root cause. Abate is nuanced, but it basically means moving important stuff away from it. So if you have a vulnerable node or a vulnerable host within your network, transitioning that host into a DMZ is a way to abate risk. Why? Because then it sits outside the firewall, and you can essentially rely on additional compensating controls to protect from all the other sorts of net impacts that can arise from an exploit on that particular box. It could also be removing sensitive materials from it. So, no personally identifiable information can be stored on this host until this is remediated. That would be an abatement. And then finally, compensating control, which is to take action to introduce a control that intercedes the risk. And so the simplest example is a web app firewall, or a firewall for that matter. You're vulnerable over port 8888. Well, I can create a firewall rule that blocks port 8888. That is a compensating control. It is meant to compensate for the risk. I haven't resolved the root cause. If that firewall were to be bypassed, I'm still vulnerable on port 8888. But for the most part, I'm confident that my firewall isn't getting bypassed. And so that can also be an additional kind of vector. So once the business makes, and ultimately this decision needs to be made by whoever owns the business risk. Typically that's somebody in charge of or reporting up to whoever owns P&L, so profit and loss of the business. That could be on a business unit by business unit basis. That could be the chief technology officer who reports to the chief executive officer. That could be a program director. It just depends on what your organization's hierarchy looks like. But ultimately, this needs to be a business level decision. Development should not be deciding what does and does not warrant remediation. They should be informing as to what the associative level of effort would be in order to remediate, or in order to insert a compensating control within the application, so on and so forth. So there's contributions of additional enrichment data into this dialogue, and it's inherently a dialogue, but ultimately somebody at the business needs to make a decision. That individual needs to be identified on an application by application basis. It may be the same person for all apps, but there needs to be an individual who is not part of development, who is not part of application security, who is making that decision. And ideally that's aligned with business leadership. And then finally, once the decision is made, you kind of have an interplay between application security and development with regards to what to do if if remediation is selected, for example.
So thank you, Thaddeus. That's a great way to translate from the application security tools into business value. But what does that mean specifically? How should security work hand in hand with development to provide effective application security? And what does that handoff look like?
Yeah, so if you think of it like handing off of a baton, what does that baton need to look like? Well, if you begin with the end in mind, application security should seek to deliver to development whatever deliverable will best facilitate remediation in that context. And a big problem that we see all the time in the world of ZeroNorth is the way that tools emit findings categorically does not align with what that baton needs to look like. And so a huge amount of application security effort goes into hammering away at consolidating findings into more kind of digestible units of developer work, or selectively deleting out false positives or known false positives that are still being enumerated in a CSV file, kind of clunky efforts like that. But ultimately the goal is to get development clear and discrete instructions on what needs to change within the application in order for a remediation to occur, essentially. So that's the goal. And that may sound difficult. It's certainly not trivial in a lot of cases, but if an application security team just produces kind of the stock standard vulnerabilities report from any of the tools that I mentioned and throws it over to the development team, you're basically relying on the application security skill set of developers to parse and triage and identify what's associated with what amidst that vulnerability result set, and then determine a pathway to resolution. AppSec doesn't need to know exactly what the resulting code needs to look like, but they need to know what code needs to be changed. And they need to have a feedback loop from development to get an understanding of what sort of a timeline or what sort of impact would that cause in terms of impacting other development efforts. So being in pursuit of that commitment, development is taking on the mantle of fixing the problems as they are communicated in a way that is copacetic with all of their other responsibilities, which is functional development and new feature enhancements, net new application development. It's incumbent upon the application security side of the house to essentially pre-bake and distill just what the development team needs to see. You'll see this oftentimes with like a security type ticket in ServiceNow or Jira or something like that, where a tasking type will be set to security and it'll have its own fields and so on and so forth. And there's like 8,000 or 9,000 of them in backlog and nobody looks at them. Whereas the development sprint board is like 15 or 20 issues. It's like total different orders of magnitude. So AppSec should be translating from vulnerabilities into task items that development can pick up and assign as part of a sprint. In addition to that, it's also about being a good scanning neighbor, I like to put it. So it's convenient to tie into CI/CD pipelines or QA protocols, processes, staging, and production deployment. It's inconvenient when you take a 20-minute build and you insert a 1 hour static assessment, because now that is a 1 hour and 20-minute build runtime. And development doesn't want that. DevOps doesn't want that because it slows delivery down. I would say the goal should be to run those assessments asynchronously. So to use those development, delivery, and release processes as triggering mechanisms for those assessments, where you get what you need from the build and then deliver that to an assessment tool, and then have a methodology for bringing that data together at the end before introduction into production, so that intelligent decisions can be made about go, no go, blocking builds, grading builds, remediation requirements, and things like that. More sort of the business decision-making side of things. But ultimately, those things, a build pipeline in Jenkins typically should not wait for your static assessment to complete in order to, proceed and deliver to your artifact repository and things like that. And then finally, identifying communication patterns of vulnerabilities and issues to development. So oftentimes standards or baselines within a business will yield a vulnerability. Well, if that's used in 5 or 6 different applications, you're replicating that vulnerability across more of the surface area of the application portfolio. So you'll see this inherently as you stand up and kind of execute on the creation of and the establishment of a proper AppSec program, but you'll start to identify opportunities for developer training where, hey, we keep seeing these same sorts of, poorly handled HTML tags or poorly handled, SQL sanitization processes. Let's find somebody who trains around this, or let's find a computer-based training module that speaks specifically to this so that we stop finding this stuff in our scans, because we've elevated our development team to have a better understanding of best practices, ways to not induce those vulnerabilities. And finally, better baselining methodologies. Consistency in the application portfolio just leads to better control and more consolidated remediation efforts, which makes AppSec happy, which makes development happy. That's sort of a natural angle.
So thank you, Thaddeus. So thinking strategically while taking a more practical approach, once you have a program up and running, can you talk a little bit about how to mature it? What do you do with this tactical program in terms of creating a foundation for more of a long-term comprehensive application security program?
Yeah, so I've alluded to this a couple of times: continual programmatic improvement, continual process improvement, enriching kind of the coverage across your application portfolio. If you're a small business and you only produce two or three or four apps, quote unquote applications, getting some level of penetration into all of your applications is not that daunting. If you're at a larger organization, we have customers that have thousands of applications, and so oftentimes it's not really a question of are we doing this with everybody? It's, are we doing this with our most important applications and then our next most important application, so on and so forth. So coverage across the application portfolio, and then again, just the enhancing the quality of development, really reducing defect density, reducing the reducing the number of vulnerabilities that appear, because you've been able to clearly and concisely communicate the issues that exist currently today within the application space of your organization to your development ecosystem, and they've been able to, through the process of remediating or abating or introducing compensating controls, come up with better methodologies to build applications on their own or with your assistance. And so what you tend to see is a big spike at the front. So the first time you scan an application that's never been assessed, you see kind of a glut of issues. Many of those may be false positive, depending on the tool you're using. Once you kind of get to that level of stability where there's issues, but you're aware of them and they're either slated for remediation or they're slated for some sort of triage, it's kind of, how do we then make that kind of continual line decline over time, and then how do we spread that across more applications throughout the application portfolio?
So we've covered a lot here today. To summarize, how can our audience take all this information and take action to stand up an AppSec program in their organizations? So how do you recommend our audience use this information to figure out where to go from here? And is there a checklist of things to do to begin building out a program?
Yeah, so I think there's a couple of questions that you can answer, or that you need to have answered, in order to begin formulating your application security program. What is your organization trying to secure? Is that intellectual property? Is that sensitive customer data? Is that service availability? Is that meeting compliance requirements? So what is the objective? What are you trying to secure? If you operate in a business where you just don't care if any of your customer data is out there on the public internet, I can't think of a business model that would prefer that, but or at least not a revenue generating one, but there may not be justification for it. I think every application that's developed should have application security as bird dogging it and keeping it honest and making sure that it's being built in a way that it can't be compromised by malicious actors. So you kind of have to know what are you trying, what are what is the value that you're trying to protect? Obviously, if your web apps drive revenue and they're offline, that's bad because you're not making revenue. So some of these things may seem super common sense, but it's worth sitting down and considering that. And then second, who's going to make the decisions about risk? Oftentimes the business folks kind of say, nope, that sounds like ones and zeros. I don't understand that. That needs to be broken down. There needs to be an acknowledgement that the salient information can be communicated in business terms, such as developer hours or development level of effort, the potential outcome of an attack. And it's not about, chicken little doomsaying. It's about being straightforward and honest about what could happen if we don't do anything with this about this particular discovered vulnerability. Next, what's the best array of tools for accuracy, performance, and cost to assess each of your applications? It may vary across your application portfolio. And then what's the best way to implement those tools throughout the SDLC so that as few people have to manually initialize assessment processes as possible? Because if it's manually initialized, it's just not going to happen consistently enough. Everybody's just way too busy with everything else that they do to fire off scans, fire off assessments. And a lot of orgs rely on the development teams ultimately to unilaterally build their own application security program for themselves. I think that's folly, namely because AppSec is oftentimes in contrast or in contest with delivery, and developers are hired to deliver software. They're not hired to secure code and then deliver software. I think the next piece is, understanding what are the communication mechanisms that you'll use to notify or alert the right people or parties when issues are discovered, and then being able to identify who needs to be involved in the conversation and who needs to be assigned work when remediation is the decision. And then finally, understanding that continual programmatic improvement, how do you measure the effectiveness of the program? And that's ultimately going to rely on how you measure risk associated with your application portfolio.
So thank you, Thaddeus. That was a great summary. And I really enjoyed our social distancing webinar chat just now. Thank you. And last but not least, we, ZeroNorth, are the sponsors of this webinar. So I would be remiss if I didn't mention that ZeroNorth does have a SaaS solution that helps organizations ramp up their application security program. The ZeroNorth platform includes 11 pre-configured open source application security tools, coupled with the automation, orchestration, centralized management, and actionable risk data needed out of the box to easily identify, correlate, and compress vulnerabilities into single units of work for the development team, and it's prioritized by business risk. It also includes a variety of dashboards, including an executive dashboard that highlights the application security posture and business risk, and it monitors the organization's progress towards remediation of that risk. There are also other dashboards that show vulnerabilities per application and vulnerabilities across the organization. So there's a lot more capabilities that we deliver that help deliver a comprehensive application security program. And if you would like to learn more about the platform, or you would like a personal one-on-one demo, please do go to zeronorth.io and request a demo. So with that, let me hand back to Charlene. We do have quite a few questions, so I know that we will try and get to as many as possible.
Right, yes. So we do have time for about 10 minutes or so, maybe a little bit longer for the question and answer. So there is time. If you do have a question for either of our panelists, please go ahead and use your GoToWebinar control panel and submit your questions. Let's go ahead and dive right into the questions that we do have, though. Here's the first one. How should SAST be used within an application security program? What are some of the best practices around SAST?
Sorry, Charlene, can you say that one more time?
Absolutely. How should SAST, S-A-S-T, be used within an application security program? And what are some of the best practices around SAST?
Yeah, so I think if I'm reading kind of the sentiment of the question, it's like a lot of organizations run static assessments and then don't look at the results because they're noisy, because they're very high in quantity. Oftentimes, organizations will run SAST and then try and use that to triangulate against the root cause of an issue. One of the things that you don't get from a dynamic assessment is what in the source code needs to change in order to fix it. It'll tell you where it's broken on the outside, but it doesn't give you instructions on or even tell you specifically what underlying component or line of code is yielding that issue. And so part of the problem is organizations will oftentimes run even open source tools like SonarQube or what have you, but nobody really looks at the information until there's a dynamic issue and you're kind of on a fishing expedition to try and find something that looks like it may or may not be related to the dynamic discovered issue. Alternatively, a lot of organizations don't use SAST because they don't have anybody to kind of curate the output to do a lot of the noise reduction. I mentioned earlier, static assessment can have a lot of false positives, and that's a weakness. But one of the benefits is it can be substantially more comprehensive than kind of your dynamic assessment, software composition analysis, and things like that, in the sense that it's identifying specific lines of code that represent patterns or structures that within the application itself that are deficient. So my take on it is, if you are using the right SAST tool for the application and your developers are aware of what the application layout looks like, oftentimes you can execute a static assessment at kind of the earliest stage that you possibly can. Like if you've heard the term shift left, which is like a big movement within the application security world, moving from kind of just the dynamic assessment of applications towards static assessment, it's substantially less expensive to fix issues that are discovered initially by a static assessment tool than it is to deliver defective code all the way up to a staging environment where it gets assessed by some dynamic tool and gets kicked back to development. You miss your delivery deadline, all sorts of stuff. So I would say SAST should just be a blanket coverage, but it should be taken with a grain of salt, so to speak.
Excellent. Okay, great. Next question here. What are the best metrics to measure the success of an AppSec program?
So I think that's difficult because an application security program's success is going to be defined based off of the principle, what are you trying to secure? If application security's goal is to prevent external actors from gaining access to the company network, that is very discreetly measurable. You can classify specific types of vulnerabilities as yielding that sort of ingress access or unauthorized ingress access, and you can measure against that. You can say, how many points are we aware of and are we reducing it? How quickly are we able to address newly published vulnerabilities as they're discovered? But it may also just be how many of our applications are we scanning and are we meeting our scan SLAs? So a scan SLA would be, we need to assess on every build, or we need to assess at the very least once every 48 hours or once a week or whatever. So there's kind of a whole bag of different ways to kind of measure the efficacy of an application security program. Now, I would say you probably want to end up with a number of different measurements that kind of collectively represent, are able to reflect the success of the program. What you don't want is AppSec people kind of gaming a measurement system to say, yes, we did this and we did it well based off of our arbitrary rubric. You want to understand what the main objective is and then find measurements that kind of align to it. So I know it's kind of a loosey-goosey response, but there's a bunch of different examples you could use. Typically, number of remediated vulnerabilities is like the most straightforward one that everybody goes to. I don't actually think that's hugely beneficial. I think the speed at which you can identify a vulnerability after your tool is theoretically able to identify it, which would be based off of the publish date or the date that vulnerability first appear within the rules engine that you're using to assess, I think that's a great measure. It means that you're focused on quickly and concisely performing assessments and distilling, new information from them, identifying what needs to be addressed. The other thing is just facilitating the communication protocol, because that has to be driven out of AppSec. So how consistently are decisions being made about risk? And if that's not happening because your risk owner on the business side of the house is, rescheduling you on a weekly basis, well, that needs to be escalated, but that's also, an impact of the success of the AppSec program.
All right, great. That was a really great answer, actually. Okay, I think we have time for 2 or 3 more questions here. Next question, is it best to plan layer/tier-wise security testing, or take a holistic approach to identify and tackle end-to-end?
So that is a phenomenal question, because ultimately it speaks to, let me just jump back a handful of slides here. Let's go here. So this is one representation of an application delivery or release cycle. But you could somewhat build an application stack on a growing application stack, for instance, on each one of these kind of stages, right? Because by the time you're executing DAST or network scanning, you have a database, you have APIs, you have a user interface, you have network infrastructure, a network interface. That's a full stack. By the time that you're assessing a container, you have a container, which is a virtual OS. It's the hardware dependencies, software dependencies, the application code itself, but not necessarily the underlying hardware. So it speaks to the fact that there are some assessments that you can and can't make depending on the different stages. You can create representative instances. So a great take on this would be, don't necessarily scan every single EC2 instance that doesn't have meaningful deviations in configuration from your baseline AMI. Just spin up a representative example of your AMI and assess that. And then you can infer, because there have been no configuration changes to that AMI across, applications A, B, and C, that the results are applicable kind of across those applications within your portfolio. If application D uses a different AMI or meaningfully modifies the baseline AMI in terms of network infrastructure or, the available ports, things like that, then you wouldn't do that inference. You would have to assess that individual application's host infrastructure discretely, and then make a deliberation based off of the vulnerabilities that you discover on that specific application. So I think, as far as DB assessments, there's an SQL assessment. Oracle has its own assessments. A lot of these things, you have to kind of look at what is it looking for. One of my favorite topics is Kubernetes security. What even does that mean? Are you talking about the containers running within pods? Are you talking about pods and what they can see and what they can communicate in and out of their namespace? Are you talking about roles? Are you talking about namespace configurations and API level access, like what verbs are available on which endpoints? Like there is so much that you can kind of interrogate about a Kubernetes environment, and everybody kind of claims to be doing Kubernetes security these days, or at least a lot of people are, and they're doing, maybe one tiny sliver. So I think the way that you're thinking about the problem is very astute, because you do want to make sure that you don't have vulnerabilities, like cross-site scripting vulnerabilities within kind of your web page. But you also don't want SQL injection vulnerabilities because you're not doing data sanitization properly on some user input, right? So it's kind of different scanning tools identify different things throughout the life cycle. And there's further breakdowns within the categories that I have represented here. So I think it's kind of a giant matrix, and you kind of got to figure out what's pertinent to your application. And that goes to finding the best tool chain for your apps.
All right, great. I think we have time for one more question here. Does ZeroNorth integrate with other software aside of the ones on the slides, such as for SCA? We utilize Black Duck.
Yeah, so, and let me just jump back to that slide specifically. So this is a representation of our Rapid AppSec program. which is the delivery of the ZeroNorth platform specifically with our embedded open source assessment tools. We do have an enterprise grade platform that supports, I think we're up to 40 some tools in total. So obviously we're looking at, I think, what, 11 here in the slide that I'm showing here. We actually have 40 tools total, and that's growing on a continuous basis. You know, basically as fast as we can add direct integrations with the various application security and infrastructure security tools, we're doing that. So it's really, you know, we do directly support Black Duck if you're on Black Duck Hub 4 or 5, which if you've done a Black Duck Hub deployment in the last, I think, 4 years, you would be on a valid version of it. And so we can, you know, orchestrate Black Duck assessments by delivering build artifacts to your Black Duck host, whether that's delivered to you as SaaS or managed hosted locally on your own network. So yeah, we do have, you know, a much broader variety of integrations that aren't specifically represented here.
All right, great. Well, we're about 4 minutes to the top of the hour, so unfortunately that's all the time that we have for question and answer period. And we had a ton of great questions come in, so if we didn't get to yours, I apologize, but please know that the folks at ZeroNorth will be getting a copy of all of the questions, and they will be more than happy to follow up with you offline. So please don't think that your question is just gonna sit out there and never get answered. So also before the end of the webinar, I did promise that we would do the drawing for 6 $25 Amazon gift cards. So let's do that real quick. Let's see, today's winners are, first is Aaron O. Congratulations, Aaron. Our second winner today is Chris S. Congratulations, Chris. Our third winner today is Eric with a K, J. Congratulations, Eric. Next winner is Joe G. Congratulations, Joe. Next winner is Nick D. And our final winner today is Trisha P. Congratulations, Trisha. Congratulations to everybody who did win or did win. We will be following up with you offline by email to get your Amazon gift card over to you. So please check your inbox. I want to remind the audience that today's event has been recorded, so if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the Security Boulevard website, so you can always go look for it there. Just go to securityboulevard.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, with that, Joanne and Thaddeus, thank you so much for a great presentation, lots and lots of really great information. So and judging from the number of questions we got, I know the audience got a lot out of it also. So thank you so much for your time and your expertise today, really appreciate it.
Thanks so much for having us.
All right, great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon and I am signing off. Have a great day, everybody. Please stay safe.